Finally, we'll draw on Kathleen. She's got extensive experience in organizational responses to disasters that will frame in ways that we can think about institutional challenges and opportunities for science communication and Icelandic horses.
Good morning, everyone. I'm going to do two things in my presentation this morning. First of all, I'm going to comment briefly on our two main speakers, and then I'm going to move on to talk about some of the work that has been done at my center, the Natural Hazards Center, around science communication.
The green button there.
The green button, thank you.
Right in the middle. Yeah. No, right at the top, sorry. This one here.
Thank you, Frank.
You're welcome.
I'm sure you found Jerry's presentation about the decline of the corporation very fascinating, and I just wanted to add to that some of the other things that are making for a very dismal future, both for our generation and future generations, such as the decline of unions, the greater tendency to treat workers as independent contractors instead of employees, the rise of part-time work and unpredictable hours, and the rise of precarity and the precariat, what we're talking about now a lot. And Jerry also talked about what not to do in the way of communicating about science. I do think, though, that through journals like Science Communication, through the activities of the academies here, other agencies, and new publications such as the new handbook on science communication, we're beginning to learn a lot about how to do it right. And as has already been mentioned this morning, we are really getting away from the information deficit model, although sometimes when I talk to scientists and engineers, I'm not too sure about that. But I think that we're really coming to understand that simply adding more information is not going to lead to greater understanding and action. There is a greater emphasis right now on the importance of ideologies and worldviews and matching up science communication with the worldviews of the audiences that we're trying to communicate with. There's a greater understanding of the importance of framing and what sociologists call frame alignment, which is bringing your message into line with the interpretive frameworks that members of your audiences are using. Affect is becoming increasingly important as we talk about science communication, and weaving affective content into narratives is also becoming important, so that the factual information is accompanied by messages that lead to positive or negative affect. There is a controversy, of course, about scientists and whether they should act as advocates or just act as disinterested, objective communicators. Should they always remain dispassionate? Should they always remain objective? I think that some findings suggest that scientists can be advocates, provided that they don't get down in the weeds and appear to be advocating for certain policies, laws, or regulations. We've already heard a lot about uncertainty. That is a really, really difficult issue in science communication, and we have a lot of problems with communicating probability and uncertainty. The favorite one, of course, in my field of disaster research is about the 100 and 500-year flood. Good luck with getting people to understand that. We've already heard from David about the importance of boundary organizations and professional science communicators. We've been talking already this morning about the need for bi-directional and not unidirectional communication, and coming also out of the words of the Academy's report on science communication, communicating in a complex, dynamic, and competitive media environment where there is rapidly evolving use of social media. Things are emerging more quickly than we can understand them, and how and understand how to use them. Lori's presentation, I think, brought home the importance of communication within multidisciplinary and interdisciplinary teams. This is, of course, important because discoveries are occurring increasingly on the boundaries of different disciplines, and also because research tells us that more diverse teams produce better quality science and science that has a greater impact. But in addition to the discussion that Lori presented about difficulties in communication that involve worldviews and the like, I want to introduce a new concept here, the concept of hierarchies of credibility. And this was a concept that was first articulated in the 1960s by the sociologist Howard Becker. And the concept refers to an assumption that we tend to have that those who have high status have the right to define how things really are, have the right to define the scientific questions, have the right to define what constitutes evidence, and that people that have lower rank have incomplete information or are misinformed. And there are hierarchies of credibility in science that I think are the basis for some of the communication challenges that Lori was talking about. Well, what do I mean by that? Well, we all recognize that there is a disciplinary pecking order in science, different disciplinary prestige with disciplines like mathematics and physics at the top of the hierarchy of credibility and other disciplines trailing behind. Within disciplines, certain subdisciplines have more prestige and are listened to and respected more than others. Lori talked about the importance of respect. There are subdisciplines that don't get a lot of respect. That's something that the civil engineers that I work with are very sad about. There are differences in the prestige of basic research versus applied research, quantitative research versus qualitative research. The prestige of academic institutions comes into play, where we might have a tendency to defer to someone from a very high-ranking private or public research institution as over against others. And of course, all that is overlaid across the pervasive significance of gender and of race when team members are communicating with one another. These are some of the things that I've learned from the work that I've done. For example, 17 years working as a lead investigator in an earthquake engineering center, 5 years working with computer scientists, many years working with atmospheric scientists and with people from other social sciences. So hierarchies of credibility, I think, are important. I want to turn now to talking about some of the work that researchers at my center are doing in the area of science communication activities. And I want to talk about really two different things where we were involved in the evaluation of science communication activities. You are probably aware, or maybe most of you are not aware, that the U.S. Geological Survey has a program called SAFER, Science Application for Risk Reduction. And one of the things that the SAFER program does is that it creates scenarios of future disasters along with other kinds of materials such as videos and animations to try to communicate to stakeholders what they can expect in the event of a disaster and to communicate with the general public. The first one of these that was done was called the Great Southern California Shakeout. That was a scenario for a major earthquake on the southern part of the San Andreas Fault, which involved a lot of work. It was extremely labor-intensive. The scenario was very elaborate. It involved people from a variety of different disciplines: economics, social science, public health, geology, engineering, and the like. The USGS then went on to develop other scenarios, such as the arc storm scenario, which dealt with a massive flood in the Northern California Delta that was caused by an atmospheric river, as well as Haywired, a scenario for an earthquake on the Hayward Fault in the San Francisco Bay Area. After the arc storm scenario, the U.S. Geological Survey brought in social scientists from the Natural Hazard Center to evaluate a scenario that involved a tsunami originating from a large earthquake and its impacts on coastal California. So one of the first things that the researchers from my center did was to develop what in evaluation research is called a logic model, to sit down with the scientists and say, what are the components of the communication strategies that you're going to be using? What are the outcomes that you expect from these strategies? And it was incredibly hard to get agreement among the scientists on why exactly they were doing this form of communication, why they were doing this scenario. So that was the first part. Then, with the scenario, this scenario was designed to inform personnel at the ports of Los Angeles, Long Beach, and San Francisco, as well as representatives from the California Department of Transportation and emergency managers. And these stakeholder representatives took part in the actual formulation of the scenario, and then they attended a series of meetings where the scientists presented them with information that was contained in the scenario. Our researchers then went in and conducted online surveys with those who participated in the meetings to ask them exactly what the impact of that participation was. And here are some of the topics that they addressed. Was the development process credible? Did the stakeholders feel engaged? Did they learn anything? Did they seek out additional information about possibilities associated with future tsunamis? Did they pass on the information? How useful and applicable was the information? And so this is a very brief discussion about what the social scientists did to find out about the impact of the scenario itself. And I just want to turn briefly to
Your time is nearly up.
My time is almost up. I'm going to show a brief video, and then talk about it.
Get a soundbite out of that. How's that?
Yeah. So I'm trying to get it. Oh, no? I can't get it to run. Oh, there we go. It's running.
I don't usually make tsunamis, but when I do, I prefer to use earthquakes. Last name Nami, first name Sue. People don't understand tsunamis, and I'm here to fix that. If you feel shaking, that's an earthquake and a tsunami warning sign. Get away from the water. The first wave could be the smallest. It's unbecoming, but destruction's my middle name. Hence, the next wave could be bigger. Nothing compares to how a tsunami actually feels. You might see water sucked out, like a really fast, really low tide. You might hear a loud sound, like a train in the ocean. Recognize these signs. A tsunami could be coming, right now. You need to get to higher ground, uphill or inland. See, I'm already making a difference. What are you waiting for? You won't get a second warning sign? Go uphill because I can't. That's just between you and me.
So I don't have any more time. I'd just like to say that this was a video that was supposed to target 18 to 34-year-olds, and that this was evaluated using focus groups in a pre-test, post-test design. And if you want to know more about this or about these scenarios, you can check with USGS, the SAFER program. Thank you.
Okay, thank you.
Sorry.